Welcome back to the channel, everyone. Today I wanted to talk about some new research that just came out from Germany about a strange species of Apeliones, which are the Harvestmen, or you might know them as the daddy longlegs. And this is a species that was found in some Baltic amber from the Eocene, so about 34 million years ago. And this particular research, called An Unusual Harvestman from Eocene Baltic Amber, presenting a previously unknown morphology of the pedipalps. This specimen is showing a strange structure on the pedipalps, which are kind of the front legs that come out of the mouth, that is not seen in any other harvestmen, and in general, this specimen is of unknown taxonomy. It could be either in the Laniatories or it could be some sort of eupnoi. The researchers aren't particularly sure. So if you're not particularly familiar with the Apeliones are arachnids, relatively widespread arachnid group. They tend to either be carnivores or kind of omnivores. They feed on all sorts of things. None of them are dangerous, but they are extremely widespread. And it is thought that the specimen that was found belongs to one of two groups, either the Laniatories, which is what you see here, which are a type of armored harvestmen. These are most common in South America. You don't really see these in North America, but what you do see in North America are the eupnoi, which is another group that this specimen might be a part of. These are the really small-bodied, super long-legged harvestmen that if you do live in North America, you're probably very familiar with seeing. This specimen was found in amber that was about 34 million years old. You can see it here. Obviously, it's hard to make out the specific characteristics, but I'll show you some better photos here in a minute. But already you can see it's a relatively large-sized abdomen, and it has these super long legs, which is kind of strange for both the eupnoi and the Laniatories. So the eupnoi tend to have smaller bodies, but the Laniatories tend to have shorter legs. So it's kind of in the middle. It's not super clear what this sort of specimen is. But what is of interest are the pedipalps, which are the kind of feeler legs on the front of the head. As an introduction, if you're not familiar, the pedipalps are up here. They are usually kind of curled in. The animals kind of hold them curled in on living specimens, and they have a structure that is not similar to that of insects. So like insects, it is these pedipalps are made up of segmented parts, or they're segmented appendages. But unlike insects, they have this additional segment in there called the patella. This is common in the arachnids, but you don't really see it in the insects. But you, generally speaking, have a coxa followed by the trochanter femur, the patella, the tibia, the tarsus, and the pretarsal claw. What has happened in this specimen, as far as anyone can tell, based on these zoomed in pictures, is that the tarsus has been split. So again, you have the trochanter, the femur, the patella, the tibia, and the tarsus with the claw on the end, but the tarsus is apparently two separate segments. So here's the zoomed in photo of the specimen in amber, and you can kind of make out the tarsal segments here. It is more clear on this side here. But the specimen has this split tarsus. It's two tarsal segments. And generally speaking, in all of the other living Apeliones, all 7,000 plus specimens of these, there is no known species with this sort of split tarsus. And Apeliones aren't super well known from the fossil record. There's only about 53 species known. This was the estimate taken in 2023. 53 was the estimate taken in 2023, published here in this summary list of fossil spiders and their relatives. It's been a couple years, so there's probably a few more Apeliones known from the fossil record, but generally speaking, terrestrial arthropods don't preserve as fossils super well. They tend to rot very quickly. They tend to live in places where it's not particularly easy for them to be fossilized. So generally speaking, terrestrial arthropods are best preserved in amber. So you're kind of limited to the number of specimens that we actually know from the past. But from those 53 specimens, and the 7,000 to 8,000 living specimens of Apiliones, there are no known species with this particular makeup. One of the thoughts for this was, well, maybe it's some sort of malformation, but because it is symmetrical, both palps on each side of the head have this structure, the likelihood that this is some sort of malformation seems kind of low. On top of that, you also have like, what are the chances that you have a perfectly preserved malformation in amber? I mean, the chances are really, really low, but generally speaking, because it's symmetrical, it's probably not a malformation. So assuming that this is a normal structure for this species, it kind of raises the question, one, what was this used for? Two, what does this tell us about the formation of appendage segments in the Apiliones? And we do know from other segments of the Apiliones that they are very prone to segmentation, unlike a lot of other insects and arachnids. The Apiliones really like their segments, particularly in their legs. So these up here, you can see the palps, but here below it is what you would normally find on a walking leg. For those of you who have never looked at a daddy long legs up close, they have just tons and tons of tarsal segments on their walking legs. And this allows them a certain amount of grasping success. They can really hold on to, fine sediment, or they can hold on to small twigs and things like that. It gives them a little bit more security when they're climbing and walking, especially since a lot of Apiliones live in trees. And this can help as well with the kind of bouncing movement that they do. Apiliones, when they walk, they kind of bounce and sway, and this is thought to be an anti-predator defense because they have these really, really long legs, which they can detach. They're really just trying to protect the central body. So the body is supported in these long filamentous walking legs, and it can kind of sway and bounce as they move. It gives a lot of flexibility in the legs, so it's harder for a predator to kind of snap at the body because it's swaying around so well. So we know that they tend to form a lot of segments in their walking legs, but it's very strange that these segments have formed in the pedipalps. One thought for this additional structure in the pedipalps is that it could be used for hunting very small prey. So a lot of Apiliones that hunt will hunt things like Columbella or Protura or Dipleura, things like that, these very small arthropods that live in the soil. And the existence of this extra segment can allow for a more bendy pedipalp, which can, grasp their prey a little easier when they go to feed. And especially since the pedipalps are going to hold on to that prey while the chelicerae tear at them, because the chelicerae are little pincers that allow the Apiliones to kind of rend the flesh of their prey and stick it into their mouth. So as always, I will link the description, or I will link the publication itself in the description. This is, as far as I know, open access, so you should all be able to access it if you want to read it. It's not a super long paper. It's like 9 pages, so it's a quick read, and you can see what the researchers have to say themselves. And I'll talk to you guys later. Thanks.